Okay, hard Maclaurins. So this is going to involve um, the standard expansions or the non-standard expansion and differentiating. It's just what we're going to do now is we're sort of going to finish off Maclaurin's using your knowledge that you now have from your normal maths. So, example 1. Find the first 3 non-zero terms of the Maclaurin's expansion. Now, in theory, you could sort of rearrange this, but it's fraught with issues. So, what you're going to do is you're just going to use the non-standard expansion, and you are now skilled at not only the chain rule, but also the quotient rule or product rule. So, f of x ln of x squared plus 3x plus 5, f of 0 is just ln 5. F dashed x, right, differentiating an ln, you take the reciprocal of x squared plus 3x plus 5 multiplied by 2x plus 3, which obviously when you differentiate an ln, you take the reciprocal of what you're taking the log of, and then you multiply by the derivative of what's inside the bracket. F dashed of 0 is going to be 3 over 5. And now you can see you have to differentiate a quotient. So f double dash. So you can see why we've waited to do this. We've needed to be able to do the product rule, the quotient rule, the chain rule. So I've differentiated this. So v du dx, which is 2 minus u dv dx. So 2x plus 2 all squared, all over v squared. And if I then substitute in 0, I'm going to get 2 times 5, take away 3 squared, all over 5 squared, so 1 over 25. And then all I'm going to do is substitute that into my formula, and I end up with this. Example 2. Show that the first 2 non-zero terms of the Maclaurin series of tan x are x plus a third x. So this is a show that question. So you've got to make sure that you give plenty of detail. So you've got f of x is tan x. So f of 0 is 0. You know that when you differentiate tan x from the work you've done in normal maths, you get sec squared. So sec squared is 1 over cos x all squared. The cos of 0 is 1. 1 squared is 1. 1 over 1 is 1. So f dashed 0 is going to be 1. F double dashed. So now what you're going to do is you're going to differentiate this using the chain rule. So you differentiate around, so you differentiate, and I know you've done this with Mrs. Reed in normal maths, the lesson that she did. So you differentiate, so this is the chain rule. So you differentiate the squared, so you get 2 sec x, and then you multiply by the derivative of sec. So what's going to happen there is you're going to get 2 sec x, and then you're going to multiply by sec x tan x. So that's going to give you 2 sec squared x tan x. And if you substitute x is 0 into there, the tan of 0 is 0, and that's obviously going to give you f double dashed of 0 being 0. And now you have a product. So you can see we are using all sorts of our normal maths now with Maclaurin's. So you've got u and v. So if you think of u is 2 sec squared x, then du dx will be 4 sec x times the derivative of sec x, which is sec x tan x. So you'll get sec squared tan x. So that's u dashed and v dashed. So if you differentiate tan x, you're going to get sec squared x. So really, you're going to be wanting to write this kind of stuff out. You know your product rule is, they've gone with u dv dx. So 2 sec squared x times sec squared x, which gives you 2 sec x to the power 4, plus v, which is tan x, times du dx. So you're getting tan x times this 4 sec squared x tan x, which gives you this 4 sec squared x tan squared x. So you can see, I mean, these are the work solutions from the Further Maths textbook, that they're really, you know, they're assuming that you're really good at these, which you sort of have to be. You have to be really good at your A-level maths. And of course, treble dash, so can you see they've just got a little error there. There's a little dash missing that I've now made a right pig's ear of trying to make look a bit better. Can I make that a bit smaller? That's better, isn't it? Right, so f treble dashed of 0 is 2. And so what you're now going to do is you're going to get your formula for your Maclaurin series and substitute them in. Okay, so you do get so you've got 0 f dashed, that's so 1x, 0x squared, and then you've got your 2 over 3 factorial. 2 over 3 factorial is going to be 2 over 6, which is a third x cubed. Right, hence find 3 decimal places an approximation for tan of pi over 10. Now that's obviously assuming that you obviously can put that into your calculator, but that's not going to get you any marks. They want to see you using this here. So all they want to see is that you substitute x is pi over 10 into there. So that's what they want to see. They want to see pi over 10 plus a third, pi over 10 cubed. That's what they wanted to see, that you knew what was happening there. Right, pause the video and have a go at this question. And of course, I'll be nice. And if I give you this to be able to work with it, there you go. So have a go at this question. It's just basically really, you can see why topics like Maclaurin's really help you with your A-level maths, because we're just assuming that you can product rule, quotient rule, chain rule, and it's just really good practice. This is why it makes you so much better at A-level maths, because you're just doing this kind of stuff all the time. There are your answers. Right, example 3. Use the Maclaurin series of sine x, I've given that to you there, to find the first 3 non-zero terms in the Maclaurin series of sine x squared. So what you're going to do is just going to replace these x's with x squareds. That's okay, isn't it? So that looks like that. Okay, I don't want that popping up. Okay, so it looks like that. Hence, find an approximate value for the integral of sine of x squared between pi by 3 and 0. So now you're starting to see a really good use for Maclaurin's. You cannot integrate this at the moment, right? You might be able to later on, but at there you can hardly integrate anything. We've recently done loads of differentiation, so your differentiation skills have gone right up, but your integration skills are still where they were. In fact, I really need to move that out. You can't see it, can you? Sorry. I'll move that back a bit. Your integration skills are exactly where they were still way back in year 12. So all you're going to do is you're going to integrate this expression. So you're going to integrate that between pi by 3 and 0. So there it is. Very good use of Maclaurins. Okay, so here are some questions to do. Taking your time, pausing the video, and there are your answers. Thank you.